Welcome back. If you have a group frequency distribution and you wish to calculate the median by hand, of course, then you will need a formula. And this ugly looking formula in front of you is actually the formula, but I'll try to break it down to make it simple. It's actually simple. So right here we have M standing for median. This L would mean your lower class boundary of the median class. You'll need a class boundary if your frequency distribution is of the inclusive type. This is what I mean by the inclusive type. Let's assume we have 7 to 12. The next class would be 13 to 18. Now you can see that the upper limit here is not the same as the lower limit here. There's a gap. So after 12 we move to the next number, 13. So in this case you have what we call the inclusive type, and when you have the inclusive type you will need to get the lower class boundary. So this would mean the lower class boundary. But if your frequency distribution is not of the inclusive type but rather of the exclusive type, this is what we mean by the exclusive type. If let's say we have 1 to 5, and then the next class is still starting from 5 to, that would be 9. Then the next class again starting from 9 to 13. You can see that there are no gaps between the classes. Here the upper interval here is the same as the lower interval here. The upper interval here is also the same as the lower interval here. There are no gaps or breaks between the classes. In that case you have an exclusive distribution, and if you have an exclusive distribution, this L won't be your lower class boundary but rather your lower class limit. By the time we start the calculation I would explain further. So but let's assume let's just streamline this example to a distribution type of frequency distribution of the inclusive type. So L here will refer to your lower class boundary, where N still remains your total frequency. So N over 2 means your total frequency divided by 2. CF right here means the cumulative frequency before the frequency of the median class. The cumulative frequency before the frequency of the median class. So that means that there's such a thing called the median class, and you are expected to have figured out what the median class is before delving into your calculations. Now for the denominator we have F subscript M. The subscript M here would mean median. So F subscript M refers to the frequency of the median class. So again the median class is popping up. The frequency of the median class. So you must have first of all figured out your median class, then you locate the frequency of the median class. Moving out of the brackets we have multiplication sign here. So this will be everything in the brackets times I. This is I here means class interval, your class interval. How do you get your class interval? For a frequency distribution of the inclusive type, you get your class interval I by saying your upper class limit minus your lower class limit plus 1. This is 1 plus 1. That is how to get your class interval. So quickly let me do a brief recap of what each of every letter or symbol in this formula mean. M here is your median. So and we say that the median is equal to L, where L means the lower class boundary of the median class, the lower class boundary of the median class. So there's such a thing called the median class. N here is the total frequency. CF here refers to the cumulative frequency before the frequency of the median class. F subscript M here mean the frequency of the median class, while I outside the brackets means your class interval. So quickly, let's solve an example. While solving an example, I always like to write out my formula, because like I would always say, the formula gives you direction. So M, which is your median, is your lower class boundary of the median class, plus all in brackets N over 2 minus your cumulative frequency before the frequency of the median, cumulative frequency before the median class, and then the frequency of the median class, close bracket, multiplied by the class interval, So you can see that throughout we kept mentioning the median class, and like I said, you need to first of all figure out what your median class is before you can continue your calculation. And do not forget that each of these are called classes. The groups are called classes, so this will be your first class, your second class, third class, all the way to your last class. So it means that amongst your classes, there's a particular class that we are going to be referring to as the median class. How do you find your median class? You find your median class by getting the median position, and the median position would always be found at the N over 2 position. So N over 2 here, N here is your total frequency, which is 50. So 50 divided by 2, 25. So our median class will be found at the 25th position of your distribution. To locate the 25th position of your distribution, the next thing you do is to get your cumulative frequency. Your cumulative frequencies by creating a new column for your cumulative frequency, and so let's extend this and then calling it CF. So you start by picking your first frequency, which is 3. You add it to the next frequency, 10. You add it to the next frequency, 17. So you just keep adding it down step by step. So I'm going to do that in the blink of an eye. Now that we are done with the cumulative frequencies, and one thing is the last cumulative frequency must always be the same as your total frequency. The last cumulative frequency, which is this guy, must always be the same as your total frequency. So that's one way to check if you've not made any mistakes. Okay, so we know that our median position is at the 25th position of your distribution. So you just locate the 25th position, and right here we can see that the last number here is 17. So it means that inside this 31 would be 18, 19, all the way to 31, and which means that it has the 15th position inside of it. The 15th position is found inside here. Therefore, everything here is the or rather, this is our median class. Excuse me. This is our median class, 25 to 30. So let me indicate that as our median class. $25 to $30 is our median class. Now we can start our calculations. Let's go back to the formula. The formula says the first thing we need in the formula is L, and I did say that L means the lower class boundary of the median class. What is lower class boundary? Lower class boundary is simply means you have to create another column for the lower class boundary, and you do that by saying your lower class minus 0.5 and then your upper class plus 0.5. So let me do that quickly, though I really don't need to do that for everything since our interest is just the median class. But for the sake of this example, let me just put it up. So I can just create another column. And call it the class boundary. Class boundary CB. So the first one, the lower class limit here is 7. So all I need to do is subtract 0.5 from 7 to form the lower class boundary of that class, and then to get the upper class boundary I just need to add 0.5 to the upper class boundary of that class. So 7 minus 0.5 is 6.5 up to then 12 plus 0.5 is 12.5. then we do the same for every other. The next one is 13 minus 0.5 is 12.5 all the way to 18 plus 0.5 is 18.5. so I'm just going to fill that up quickly and I'm done. So I have my class boundaries. However, our interest here is the lower class boundary of the median class, and don't forget that this is the median class. Definitely all we need is just this, and this would be the lower class boundary of the median class, 24.5. so I can indicate that also, 24.5 as the lower class boundary of the median class. Note that if we add an exclusive frequency distribution, this class boundary here is similar to the exclusive frequency distribution, because for the exclusive frequency distribution, the upper class boundary of the previous class is always the same as the lower class boundary of the next class. So this will be the same as this will be the same as this will be the same as this. So this looks like the exclusive type distribution. If your distribution originally is of the exclusive type, you do not need these class boundaries because there is no gap in the exclusive distribution. Just like this, when we have 12.5 here, the next one will also be 12.5, so there's no gap. The essence of the class boundary is to bridge the gap that we have in the inclusive type. There's a gap here. After 12 we move to 13, so there's a gap. Unlike this, after 12.5 the next is to 12.5. so the class boundary is introduced to help us bridge that gap. So if you have the exclusive type, you don't need class boundaries because there are no gaps. You just use your lower class limits directly, the lower class limit of the frequency class directly. But because this is of the inclusive type, we need to bridge that gap, so we introduce the class boundaries. Then we are going to be using the lower class boundary of the median class instead. So moving on, we've gotten the value for L. L is 24.5, the lower class boundary of the median class. Then I think we can start our calculations. Okay, so we have our L here as 24.5, then plus all brackets n over 2. N over 2, we know that n is 50, so n divided by 2 is, okay, let me just put it directly. So we know that n divided by 2 is 25, minus the cumulative frequency before the frequency of the median class, or rather the cumulative frequency before the median class. Note that these are your cumulative frequencies, right? So we know that this is the frequency of the median class, and this is the cumulative frequency of the median class. But instead, we need the cumulative frequency before the median class. So this is the cumulative frequency before the median class, 17. That is the cumulative frequency before the median class. So we write 17. All divided by F subscript M. F subscript M means the frequency of the median class. We know that this is the median class, and this is the corresponding frequency of the median class, 14. So 14, close the brackets, multiplied by the class interval I, the class interval. And I did say that your class interval I is gotten by your upper limit minus your lower limit plus 1. So in this case, our upper limit for the median class is 30. We have that here, 30. This is the upper limit, and this is the lower limit. So we just say 30 minus 25 plus 1. 30 minus 25 is 5, then 5 plus 1, that is 6. So our class interval is 6. And our mean, or rather our median, would be equal to, bring back my best friend. So I just impute this directly in my calculator. I have 24.5 plus, can open the brackets, the fraction sign, another fraction, 50 divided by 2. Oh, okay, instead of, okay, let me just give it 50 divided by 2. I wanted to skip the 50 divided by 2 and just write 25 instead, but let me go ahead. Divided by 2 minus 17 divided by 14, close brackets, times 6. So the answer is 27.929, rounded up to 3 decimal places. Alright, I'll see you guys in the next video.